Hello everyone, I'm Salih, and in today's video I'm going to be talking about some background task services or background services or anything happens in background in WebApi, .NET Web APIs, and I'm going to make you reimagine how you can manage these tasks behind the scene with a background worker. The topic that I'm going to talk about is that channels. It's called channels in C#, and there are a bunch of other resources by mostly Microsoft. If you go to learn Microsoft, you will see that the channel is basically under the System.Threading namespace, and you can read a bunch of things over there. And also, Stephen Topp, who has invented that channels, has a blog post from 2019, as well as a video from 2020. I guess it's 4 years ago, but this is 5 years ago, and this is I don't know how years ago. But I'm going to talk about this channels and how we can reimagine doing something behind the scene while we have a standalone web applications. So let me quickly show what I have here. Imagine that we have some tasks that we receive by an endpoint, and we need to process them. Maybe I've got 20 numbers and I need to do with that numbers, like do calculations and insert a database and create something else. It really doesn't matter, but it may be a long process, or it may be a batch process as well. And in a normal world, if I had a concurrent queue, I would add every item to that queue. So I would be the producer. I'm producing a message and putting it somewhere that I can access later. And also, I would have another consumer that consumes that queue, so gets every messages and process by. And for that one, for example, we could use background service in .NET, I can say. In C# web application, we've got called background service. It used to be called hosted services, but this is the base class that we use. And it gives us an execute async function. So within that execute function, I would think, okay, this could be my consumer. So whenever I put something into my queue, this consumer would consume the message and delete it from the original source so I can add later, right? So this could be a very simple explanation. For example, I have a service and it's got concurrent queue item in it, and we've got a couple of functions over there and count as well. So I'm enqueuing something, adding into the queue, and also dequeuing, so removing from queue. And this hosted service basically is consuming, but it is pulling sort of mechanism. What I mean by that, it always goes to queue and says, okay, do you have any item for me? If you, for example, if the count is greater than 0, if you have anything, let me dequeue it and then process. It really doesn't matter what you do with that, but I'm just going to print it on the output. And then wait for a second, and then again, go check queue if it says any item in it. If says so, okay. If doesn't, okay, wait another second and do the same thing and do the same thing and do the same. This is pulling sort of mechanism. And we can add the items from by calling this endpoint. For example, if I say 10, it is going to add 10 items, and it doesn't have to be actually. So we can have next numbers between 1 and 1000. So I'm enqueuing random numbers this many times. So this is going to be okay. So let me run this application first and see how it behaves. I'm going to go to HTTP file and send request. By the way, item count is 10. So it is going to make 10. But I will see, okay, my processor, so I will say consumer, is basically retrieving all the messages and processing it. So there's no harm on that. The problem over here that there's a thread that all constantly checking if any item is in the queue, if any item is in the queue. It is not smart enough, I would say. And plus, as it is waiting for 1 second, if I have a message that I need to process right away, just whenever it's in the queue, I need to process, then this implementation doesn't care about it. It's because it is going to wait for a second to have another item, right? So wait for a second, have the another item and process it, and wait another second and do the same. So you can dequeue everything from here once. You wouldn't have to wait for a second for each messages, but for every chunk, So whenever I call the endpoint, I will know that this messages will be processed 1 second later at least, or at most, I can say. But this is not good enough. This is not smart enough. What I'm going to show you is that channels, and we can make this implementation even smarter. So how we are going to do that? So I'm just going to have the polling backend service over here. I'm not going to delete those so we can compare it later. But what I'm going to do is I'm going to create something generic. I'm going to call it back. Now I have a generic type of queue, right? So this is going to be my queue, but you don't have to make it generic, and you can implement it however you like, but I'm going to try to create something that we can use later as well. So this function is going to have, enqueue item, right? So I'm going to enqueue something, as well as I'm going to dequeue, but let's say dequeue task and async. Let's make it can be async as well, enqueuing, but in that case, it really doesn't matter. I can return count, or I can return something that is even smarter. Boolean, I can say wait for the next read, or has next, or it really doesn't matter, but it is going to be called to determine if I have any other item. It can help us. By the way, this could be value tasks. This one as well. So I need a space where I can hold my item. I can store my item so someone else would dequeue it, right? So this is where I'm going to create channel. Channel is under, as I said, T, and let's make it channel within that way. So channels are in system threading namespace. And while creating a channel, I'm not sure if you're familiar with RabbitMQ, but RabbitMQ has channels, and it is basically a channel between consumer and producer, right? Someone is going to produce something and someone will consume it. So RabbitMQ creates a channel between those endpoints, consumers and producers, and sends the message, all the messages through that channel. This is the same thing, actually. We have a channel, has 2 endpoints, writer and reader, we could say, or producer or consumer, we could say. But in that case, it is reader and writer. So channel's reader is going to be the producer. Consumer is going to consume and read every item that we put into that channel. We can create that channel within 2 different ways. It's called bounded and unbounded channels. And I'm going to continue with unbounded channels over there. Let's create channel unbounded, like that channel, and it is going to ask me to produce unbounded channel options, I can say. And this channel is now going to be used to put the messages in as a writer, and it is going to it's going to allow you to read by using its read function. So I have channel, so I need to say, okay, actually this can return Boolean. It's because the enqueuing could be success. Try channel writer. It's because I'm gonna write, and it says, okay, try write. It could be false, it could be true. I'm going to show you what else options we have in this options in a minute, but keeping that way in right now. And I need to dequeue it as well. So return channel reader this time, and read async. Now I'm reading the async, and we can use cancellation tokens as well here. Let's say token and default, and it could have been passed here, and let me do the same for here. And channel also says, okay, wait to read async function it provides, so we can use that, but it really is not necessary, but I'll show you how we can use it. So now I have this background queue service, and I can use it however I like. So what I'm gonna do is to have another hosted service here. I'll say queue reader 1, right? It is going to be background service, and I'm going to implement it. So in this async function, I will inject my queue and I will consume it. So what was my queue? And it is called background queue service. And I'll say, okay, primary constructor. I'll have it as an integer. You can use keyed services as well, but I'm just going to make it type specific right now and say Q. Okay. So within this execute function, I have a while loop over here. I'll say, okay, Q, my Q has wait for the next function. I can pass the stopping topic even, and it is going to be awaited. And if it is awaited, make it async. And if I have any value, I'll say, okay, give me the item. It really doesn't matter what it is, but dequeue the item and do, let's say, Q reader 1 value is, or number is, doesn't matter. This is the item. So this background service is going to consume whatever I have, right? So let me inject these two into my, let me put it within that way, Q reader 1. And also I will have to inject my background Q, this one, and let's make it singleton. And this is going to be an integer. You can have string consuming queue, you can have batch operation model or view model or request any item. So you can create whatever you like on top of this one. So now I have background service and I have queue reader. This is going to be started by dotnet itself, and this is going to be consumed by this guy over here. So what I'm going to do, I'm just going to have this one and add another endpoint. So let me copy this one. And let's say add Q also. Add to Q. And the same thing, this time, instead of Q service, what I'm going to have is this one. So this is going to be my Q. And I will do the same actually. So instead of the other one, I'm going to make it enqueue. This is, yeah, synchronous. So this is the queue. So if I go my endpoint file and if I copy this and get rid of this polling queue part, right? So now I'm going to run the application. By the way, I can disable the others, so we wouldn't need those guys. Go program CS and get rid of these two like that, yeah. And run the application. So we can see both at the same time, yes. And let's get rid of this guy. And I'm now going to call this function with a 10 item. It is going to add every item, and I'm going to have something else there. And go here and pin you and make the request. So as you see, as soon as I make the request, I've seen each item. So I've seen a delay, just a bit delay over there. It's because not this, but not this, and this one, and also this one was waiting for 50 milliseconds, for instance. So let me rerun this. I just removed that one. So the second I hit this endpoint, I will see a bunch of messages at the same time read by QReader1, and the value is basically the random value. So this is not poll based. So my application, my QReader, it is not polling. So let me debug this. So when we call this function, it is going to make the current thread wait for the next iteration. So it needs to wait for someone else who puts the messages into that channel. Then it is going to allow me. So let me hit that endpoint again. So see, I'm still debugging it. So it says, okay, I have an item in my queue, so you can have it. So it is basically not delaying, it is basically waiting behind the scene without blocking my whole operation, without blocking my whole thread, without blocking my whole state machine over there. There's a smart pointer, smart wait over there. It's thanks to the .NET framework and C# and Stephen Tob. Though I'm now using as it is smarter way, in a smarter way, and I'm in dequeuing and doing all the stuff, and it happens once. So I told you smarter way, but this is not only way we can use channels. It's because channels got, let me make it a bigger again. channels got single reader and single writer properties, which both false by default. So within channel, we can have multiple producer and or multiple consumers. And by default, single reader and single writer false. So by default, it means you may have different threads to generate messages, puts it into the queue. Also, multiple threads that try to read. If those guys are true, those messages are true, those properties are true, that means that you guarantee that there will be only one producer, one thread to produce the messages, and also one thread to read the messages. If you have more than one, within that case, if those properties are true, it's going to throw an exception, says, okay, there's a problem with that. You told me that there's only one reader, but I am accessed by too many threads, or more than one thread. So to be able to avoid this problem with this concurrency and race conditions or something like that, so we need to make sure that if we are going to have a single point to read or write by choosing those properties and deciding what those are going to be. And let's make another example. So I would have one, but I'm not going to create the second queue that reads the messages and says, okay, this is queue reader 2, and this is going to be reader queue reader 2, and the rest will be the same. I will have to inject this one as well. Copy one and copy reader. So in that case, now I have two readers. So it means two consumers, but 1 point writer. So if I go back to my configuration and say single reader is true, when I run this application, it says, okay, there's a problem with that one. It's because you told me that there will only be one reader, but you are trying to read the data from two different tasks. That's why two different threads, I would say. That's why it is not failing. If I had this property as a false, I still have a single point of writer, but multiple reader. Now, it is not going to complain about this one this time, so I will have no problem with that. So what happens if I have multiple data right now? Let me generate more data. If I do send request, I would see messages are distributed, but it is not evenly distributed. It's because within that case, whoever wants to read the data, and this is a race basically, whoever wins the race is going to receive the messages. In our case over there, for example, QReader got 1 and 2 only, but TrueReader was even faster to produce those implementations and says, okay, it's got 8 messages. If I had, let's say, if I had delay here, so yeah, let me open that delay and now rerun the application. And this time I'm going to hit the endpoint again. We will see evenly distributed messages. It's because I gave them some time to be able to process the item, and also the other one would get the message while the other one is basically processing the message. So the first message went to queue reader 2, for example. While it is doing its job, the Q1 just comes in and the other one finishes by that time, and the other one process it in, and so on and so forth. So we can see 1, 2, 3, 4, 5 items picked up by QReader 2, and 5 also for 1, but no messages are duplicated. So to be able to prove that, I'm going to add the item so we can see if we are having the same items twice or thrice or many times. But as you can see, no, it is always the number we've generated from there. And this is the channels I wanted to show you. This was unbounded. So if we had bounded queue, let me copy that first. I would say bounded channel options, yes, and it's got capacity. So if you say so, okay, I will have many items in my queue, and I will have consumers that is consume that queue. But if I have too many items in that queue, I want to have a limit. So my queue has a capacity. For example, here it is 1000. This property is capacity. Let me get it that way. So this property is called capacity. Now I am limiting my queue. So I can only have 1000 item in my queue, and as long as my consumer is consuming, I can have more. But if we have capacity, we would have another property over here, which is called full mode. Within that full mode, we can decide what's gonna happen if I have the maximum number of items in my queue and someone tries to add something new. So I can make them wait. So let's say you have 1000 item in that queue, and 1001st item is waiting in that case. But it doesn't have to be waiting. So I can drop things. So I can say, okay, drop the oldest item in my queue so I can have something new, or drop the newest. So basically you're making it to behave like stack or queue. And you can drop oldest, you can drop newest, you can drop write. So whoever is writing something, you can drop that one. So you could still preserve your 1000 or maximum capacity of items from that one. Or as I just said, you can make them wait for some consumers receive one of those messages. So you would have extra space until that one. You can make them wait. You can create your own smart queues. And this is, I believe, one of those most efficient way that you can have background queue tasks. You can create your own implementation on top of channels. You can get the benefit of bounded or unbounded. You can get the benefit of having a multiple reader, multiple writer. And multiple means in that case, it's going to be able to process all those concurrency problems like race conditions, or I don't know, multi-thread access, the same thing. But if you like this content and if you like channel, let me know what do you think about channel. So if you would use those channels and different versions of it in your project, or how you are basically managing background task, background queues in your web API project. By the way, this doesn't have to be a web API project. You can have something like that within this console application even, or I don't know, Windows Form application, your MAUI application. It really doesn't matter. It is pretty flexible, so you can create something flexible on top of those channels. So let me know what do you think and how you manage those channels. And also, if you like that content, please hit the like button. And if you're not subscribing me, please subscribe. And until the next time, happy coding.